Okay, so I'm going to tell you kind of the big picture, most important things you need to know about producing from oil and gas wells, and of course, what that is. Okay, if you have pressure and you're able to get oil and gas to just come up from the pressure, that's great. And that's kind of the first step. But at some point, that pressure is going to decline. The oil and gas isn't just naturally going to come up your well. And so you have to decide if it's worth the cost to continue to get the oil and gas out in other ways. So that first step is called primary recovery. The other thing that we do during primary recovery is pumping. So you can see behind me are pump jacks. That's just a pump that is pumping, it's pulling the oil out of the ground rather than just having it come up by pressure. And so we do that. That's kind of like the first stage. Natural gas is pretty much all from this natural flow. But say we want to get more than just 12 to 15% of our oil out of our reservoir. We have to do other things. The second thing we can do is secondary recovery. And this involves injecting water or natural gas or sometimes, other things. We can inject that somewhere into the reservoir and push it towards our producing well, and then we can get additional oil production. So you can just think about it, it's just something that's pushing that oil through the reservoir towards our producing well. We can get another 15 to 20% of our oil in place. This is done a lot of places, but honestly, it can be really hard to find something that's cheaper than oil to inject into the reservoir. So even things like bottled water is much more expensive than what we're paying for oil. So in places where we have excess natural gas or we have a natural place of CO2 or something, we can do secondary recovery, but it's not done everywhere. It depends on what's available. Then if you want to even go to a further level and get some of the really hard to get oil out of the ground, we have to do something called tertiary recovery. And so this is really unconventional. This is where places where we're really doing more things to get the oil out of the ground. One of those ways is something called thermal recovery. And it's something that we do here in California because we have really heavy oil that doesn't flow well. And so this thermal, we're really putting steam into the ground, we're heating up the oil to make it flow, and then we're getting it out of the ground. This is the picture that's behind me, and this is what it looks like. Because that heavy oil that we have in California doesn't flow well, you have to have a lot of pump jacks. And so really you have steam injection all around the pump jack, trying to make the oil viscous enough to flow, and then it'll flow up into the production well. And so you have to have a lot of production wells all around to get that oil out of the ground. All right, so we talked last time about how oil wells are a little bit different in the US than anywhere else because the mineral rights are privately owned in the US, unlike other countries where mineral rights are usually owned by the government in almost every other case. This leads to a few things in addition to some of our energy security tax measures, leads us to really have way more oil wells than anywhere else in the world. And the average production of those oil wells is really low. So this is partly because we have a tax break for these low producing wells. That is done to promote energy security so that we're producing oil domestically. And you can see we're only producing, on average about 12 barrels per day. Compare that to Saudi Arabia that's producing over 3,000 barrels per day for each of their wells. So really low producing. You get a tax break. And of course, if you want to access your own mineral rights, you have to have your own production well. And so all of that leads to us having a lot more wells than anywhere else. So hydraulic fracturing and horizontal drilling revolution really opened up more oil and gas production in the United States. You can see now it's well over half of our oil production. Just to put that in context, we only have 4% of the reserves, but again, we're the largest consumer and largest producer of oil. It's a similar picture for natural gas, although you can see here the hydraulic fracturing and horizontal drilling really opened up even more natural gas and some natural gas only plays. 7% of the reserves in the world, but still, again, the largest consumer and largest producer of natural gas. This revolution also led to a change in where we're producing oil and gas. And so one of the challenges with changing where we're still producing a lot in places like Texas and Oklahoma, but suddenly we were producing oil and gas in North Dakota where we never had before. And we didn't have the pipeline infrastructure to do things like capture the natural gas. So when we were doing this new production, one of the challenges we had was that natural gas was vented or flared, or new pipeline infrastructure was built or wanted to be built. And then there was all sorts of challenges in terms of the disruption to the environment, Native American land, et cetera. So lots of challenges there. This global venting and flaring of natural gas that's associated both with natural gas production and more so oil production is really a challenge for climate change because methane is such a potent greenhouse gas. Even when you're flaring it and you're trying to turn it to CO2 to make it a less potent greenhouse gas, a lot of those flares are very inefficient. So you do get a lot of just natural gas going into the atmosphere. So it's something that remains a big challenge with our oil production system. All those oil and natural gas wells, historically, and the ones that we have today, lead to a big legacy issue. We have almost 4 million abandoned oil and natural gas wells. Those are leaking, venting, things like that. And it really is left to local, state, and federal government to clean those up. Finally, just two little slides on offshore production. You can see that the majority of production is onshore, both in the world and in the US, but there is, almost a third of oil and gas produced offshore. It's a much more challenging environment to produce offshore, tends to be a lot more costly. And especially for natural gas, it really has to be done relatively close to shore because it's hard to transport that natural gas from an offshore rig. And then, of course, you can have accidents, both onshore and offshore, but the offshore ones can be really hard to manage. One of the most prominent offshore drilling accidents was the BP Deepwater Horizon. That was one of the most costly and the most damaging offshore drilling accidents in the world. That happened off the coast of the Gulf Coast in the United States. That kind of thing, it took a long time for us to get it under control. The ocean is a really hard environment to work in. And really was caused by a failure of that blowout preventer and also not doing a good job in checking the casing and the cement casing that we talked about. So all of those things led to that accident. Okay, that's all I had to tell you guys today about producing from oil and gas wells. If you'd like to learn more about it, check out the full lecture on our website. And of course, you can also just learn other things by joining our newsletter.